Okay, today I'm going to work on making a some sort of complex, rhythmically complex sound without a sequencer. So I want to do it with cross modulation and looping maybe, but not an explicit sequence. This is inspired by a lot of sort of experimental noisy people. Heinbach, I've been watching a lot of his videos recently. Okay, so one of the other things I want to use is some karplus-strong synthesis, which I don't actually have built out in my system, so I'm going to have to do a little bit of work in the Rust that drives my underlying audio rather than just in the dynamic live coding tool, which I would otherwise use. So let's look at that. So my system is conveniently called Instruments because it doesn't actually have a name. Yeah. So Instruments is the placeholder. 7D graph is where I'm putting all this stuff for lack of a better place. So this is the system is a DSP graph, and every node in the graph processes signal somehow from 0 or more input ports and outputs a signal to 0 or more output ports. And they all have a similar structure by implementing this node trait. So here you can see the last thing I wrote, which is a real simple reverb. So what I need for karplus-strong is I need a very short delay line, and I don't currently have a good way of doing short delays. I have some stuff for doing longer delays, and this reverb, which has delays in it, but I don't have like a delay line extracted out. No, actually, I don't have a moddable delay line, is the thing. I have one that's sort of static, but I'm just going to start over. So what I'm going to do is I'm actually going to just copy this reverb code, because that is 100% class. And instead of reverb, we're going to call it moddable delay, because I think there's already a thing called delay that just doesn't have the parameters I need. And I don't need most of this stuff because I'm not actually setting up a delay. So I need the actual struct. Okay. So this is going to have only one delay line. The reverb is stereo. And I don't know that I care about the sampling rate. I guess I do. So it has one delay line and one index. By delay holds 8 wide F32. So this is an explicit SIMD thing. Mostly I'm just using it as a block. So my graph computes 8 samples at a time in those blocks for the most part. I've got some stuff that runs at different rates, but for this it's going to be in that rate. Okay, so this sets up a relatively short. So this is giving me a vec of blocks of samples initialized to 0, and it is. I'm assuming something about the sample right here that I'm going 44 kilohertz, which I don't actually know that until runtime, but just to allocate this memory, I'm doing it here. That could be cleaner, but whatever. So this gives me a small fraction of a second, which is the appropriate length for the delay line. I'm trying to think, for the karplus-strong, I want a really short delay line. This may even be too long to really work with, but I also want to be able to shorten it. So we'll just stick with this and we'll see. So that gives me 0.09 seconds worth of delay line. All right. And my reverb was taking in basically the parameters I need. So this is where I define my input ports and output ports, and they're in these tuples because I have refactoring I need to do to make this all cleaner. But right now that's what it is. So now I'm saying I take 2 input ports. One is a floating point at control rate, and one so not in these 8 wide blocks, just one floating point at a time, and the other one is an F32 block. So this is sample data, and then I'm going to output sample data. That's what that says, because that is how we're going to do. And it's to be called laudable delay. I'm not going to put the filter or anything in this. I'm gonna patch the filters on dynamically, because I think that'll work. And then this is a little more generic. Okay, so this is, instead of getting a stereo signal, it gets a mono signal. It's fine. And then I don't need most of this because this is all about my multi-tap stuff for the reverb, which is not at all relevant here. So what do I need? I need might as well unpack reference, because I may not need that for this, but that's what the code does. So we'll just do that. Cool. And this sample rate is, once I know the actual sample rate at runtime, this gets called by the framework, and then I record that. Yeah, I'm not actually sure I'm going to need it, but okay. And I constrain my length to be something that is maybe too long for karplus-strong. So this is my length parameter, and this is a fraction of the total length, which is a little bit awkward for this, because that's not really how I want to be thinking about it. But I think it's going to work for this. And okay, so I only have one tap. It's at the end. But I still need this logic for like figuring out the index stuff, so I'm just going to preserve that. So length is no, that's a gain thing. This code is the result of me fiddling a lot with the reverb, so there's some technical debt, as the kids say. And the FTI. So the FTI is actually just my one. So what I'm doing here is I have my my current index. Just get this over to the right indentation. Because in my heart, I'm still a Python programmer. Okay, so I take my current index, I subtract, because I'm moving backwards for the tap thing. Do I care about this? No, this is too complicated. That's only for the delay. I should probably just edit this out because it is kind of silly to watch me do this. Maybe this is how code actually happens. I don't know. Not good code. All right. So my index actually is going to be the so Lin scales the length of the delay line. So it's actually going to be star IDX equals star IDX plus 1 mod the actual length of the thing, which is delay len, that's a float, times my modulation parameter. No, but I want to go backwards like I did with the delay line, so that this is actually not quite right. So this is actually just going to progress forward. So it is +1 mod the actual. Okay. Is this what I want? Yes, it is. Yes, it is. Okay. Okay. So this just gives me a looping index through the delay line. And every sample block I move it forward because the delay line is itself in blocks. That is coarse enough that it might matter for the karplus-strong, so I might have to store my delay line in individual floats instead of floating point blocks. I don't know. Let's see if that sounds wrong. Okay, so now I've got that, but now I want to know. So that's my input. So now I'm going to go. X. I know this is in range. Yep. Okay, so this is set to be my signal. I get this weird 8 sample chunk, which I'm a little worried about that. Okay, so now I need a new IDX. Previous IDX. This is the sample line end. Let's call that the sample at the end of the delay line, taking into account the current scaling. I think that's what I want. So that is also. I've already unpacked this reference. I clearly didn't actually need to do that, but it's just how it is. Okay, so that is my current index minus. So make it a signed value because it's U32 or U size, so you'll be able to subtract stuff from it. Then U32. Okay, so that gives me a possibly negative value, and that is the. Let's just do this floating point. Because that's how it used to be. Okay, because I need to take this, scale it by my modulation value. Right. So this gives me the sample in the delay line before the current sample that represents the end of the delay line scaled by the current thing, but it's possibly negative. So I need to make it positive. And I can assume that len is always less than or equal to 1, between 0 and 1, but let's just not make that assumption. So while line end is less than 0, we got to go line end plus equals, I need to make this mutable, delay len as f32. Maybe I should just call len once, but let's just hope the compiler knows how to optimize that away, or it's fast enough it doesn't matter. Cool, so now I know it's positive. Do I know it's within range? It probably is. Whatever. Just to be sure. And loop by delay len 32. Okay, so now I have a floating point number that represents the correct index. and then we get that value. I know it's positive, so this is fine to do. Okay, that gives me a relatively simple delay line, which I can, maybe not like that. I'm trouble with my language server bindings here, so I can't actually get the error message for that. So instead, I'm going to have to go actually compile it, do the check. That's another thing I need to figure out. Oh, was this already floating point? Who's those? Oh, it's a reference for these guys. Okay. I'm not using per sample here. I don't think I need to. That was important for the reverb version, but not for this, which means I don't actually need to respond to this signal at all. There's a default implementation, there's nothing. Also don't need those guys because I'm not actually going to build results. I'm just pulling it out of the delay line. Okay, cool. I think that's good. Okay, so now I need to make a version of this that I can use in my live coding side. So I do that here in this really ugly list of macros. Someday I'm going to make this more automated, but right now it's super manual. Pretty sure I don't have anything already called delay, but let's just double check if that's true. So these are basically all the keywords I have. Did I just redo? I think, let me just double check that I just didn't do the super dumb thing. Sorry guys. Delay line. This is a stereo delay. It is not moddable. And it takes a fixed size length. Whatever. Okay, so this is actually kind of garbage to have the dynamic set. So I'm just going to take it out and replace it with this moddable delay, which actually does what you want for the live coding stuff. Why are you unhappy about that? Expected value. Oh, this is actually need to build a thing. Cool. And then that's going to give me warnings that I'm going to ignore because I am a good person. Okay. So now I've got that. Now I've prepared this basic patch. So it's a double check that this actually compiles and runs, and we should hear a sine wave. Hey, okay. So this is my sort of blank patch that I'm going to start with. And silence that because I don't really want to listen to it. Okay, so now I have a real basic patch. I have a delay line in my vocabulary, which I didn't before in a useful way. So what I'm going to do is I'm going to give myself a trigger source. And we're going to call that tempo because that's what I call it. It's going to be a sine wave, which is probably what I want. And we'll do 120 BPM. Great. So in this language, I'm defining my DSP graph by defining nodes where I have a symbolic name for the node, just a variable name basically, on the left-hand side. On the right-hand side, I have a constructor for the node, and that's the thing I set up with that macro in the previous file. So in this case, I'm constructing a sine wave nodes with a default frequency of 2 hertz in LFO. Everything I assign here is being set as default values on input ports, which I can also patch to if I want to mod it. So this one was on audio rate 220. These are patches where I go to a destination node by name. Output is a default node that just plays the sound. A default input port, or I'm sorry, an input port number on this input node. So output has 2 input ports. 0 is left signal, left-hand signal, and 1 is the right-hand signal for stereo. And then the final value is an expression of some sort, which can be other nodes in the graph, constants, or math involving nodes or constants. So that you can write little expressions here. And that is basically all that this language does. And every time you save the file, it reconfigures the graph to represent what you've written. So I can do things like increase the volume of that a little bit, write the file, we hear that change, set it back to 0, write the file, we hear that change. Right? So that kind of stuff. And it's not as slick as some livecoding languages, but as a development tool, it works. Okay, so now back to what I was doing. So I have a tempo, my LFO, two pulses per, or 2 oscillations per second, which I'm going to treat as pulses. Now to do karplus-strong, I need some sort of noisy source, and I'm going to use actual noise. So I'm going to make a noise. This is actually a wavetable that just has white noise in it, called noise. And so I can sample this, or I can use it. So now what I need bursts of this. So I could make short gates. I don't really have a way to do short gates. I might actually be able to do single sample impulses. I don't know if karplus-strong works with that. But let's just do an envelope. So noise, because I know I can do this. So this is a attack and decay envelope. And I'm going to give it a really short, I guess I'll just give it just a decay. So a 0 attack and a really short decay. And then it's going to trigger off of the tempo. So this will give me these really sharp peaky envelopes twice a second. And then I'm going to first, let's just listen to that and see if it sounds the way I think it does. So if I go noise times noise envelope, and because my expression parser is not great, I need to, I always have to have parentheses to disambiguate everything. Someday I'll fix that. And just because that's going to be loud, we're going to bring it down a little bit. So now we should hear little blips. No, we don't. Why? This is too short. Oh, what have I got a typo? I don't have any errors in the editor at this point. Cool. Okay. So what I did here is I looked at the engine running, and it's graphs must not contain cycles is my default error message, because I'm classy and haven't made that better. In that case, there wasn't a cycle. It was just I had typoed a node name, and so it couldn't build the graph. Okay, so that sounds like a hi-hat tap or something. Make it a little bit shorter, maybe. And that's a pretty good tick. Okay. So that's probably good enough to drive a karplus-strong, to the extent that I know how this is going to work. We'll see. So now we're going to build a delay. I'm going to call this QPS delay. And what were my parameters? I just had a length. And I started it relatively short. Yeah, I'll just figure that out. So that's my length, which is a value between 0 and 1. That just is the proportion of the maximum length of the delay line, which is relatively short. And then I need an input. So it's going to take the same thing that I'm currently playing to the speakers, which is noise times noise envelope. I think the karplus-strong to really work is going to need the signal to be pretty loud. So I'm probably going to have to scale that some more, but we'll just do that. Okay. So now I've got a delay line. Theoretically, this should sound exactly the same as what we're currently hearing, just offset by a small fraction of a second. So there should be no audible difference. And that's what we expect. Okay, so it sounds exactly the same. But we're going to fix that. So what we're going to do is we're going to make this recirculate. My graph, as they're currently set up, can't have cycles. They have to be acyclic. So to make cycles, what I do is I set up these things I'm calling bridges, which are basically a one sample delay line. And I actually have a little syntax for that. So a bridge goes, keep this in, it has an inside. So this is a node that represents the input for my one sample delay line. This is a node that represents the output of my one sample delay line. And now I can use those in expressions without making a cycle that will confuse the topo sort that is used to determine the order of execution. What I want to do is I'm going to patch that KPS delay is my source. It's only got one, the input port is actually 1, because that's where the signal goes. And it's going to get the output of my bridge. And then I'm going to patch the input. I'm just going to loop. Well, no, I know I can't do that, so I actually need a filter. So build the filter first. So this is filter. So what I want is a low-pass filter. So this is an SVF, a simper SVF low-pass filter. And because I know that I need to filter the values that are going through the delay line. I don't really know what the right filter is, so we're just gonna guess. 400 hertz seems right. It doesn't need to be resonant, doesn't need to be driven. Two parameters, and then it takes a signal, and the signal is going to be the output of my bridge. No. Is going to be the output of my bridge. Okay, so now I have a filtered version of the ticks coming through. And let's just double check I've got everything, that sounds approximately right. So this should be quieter, maybe silent. Silent. So it thinks it's running. Oh, I got myself confused with the bridge. Okay, so those ticks are very quiet. Hopefully that's audible in the recording. But they're there, so that's what we expect. This is what it sounds like with that filter. Raise the filter really can make it louder. Yeah. Okay. So now this node, KPSF, has the filtered value of the delay line. So we want to put that into the input. So the source or the destination is the KPS ins. It's the input side of that little delay. It only has one port, and we're going to give it KPSF times a pretty serious gain, because I think there's otherwise this might get real loud. So now we should start to hear karplus-strong, I think. Okay. I got some value, bad value in there. Okay, that is too much. Not really sure why that's my threshold. No, sorry. I have to actually write the file. Cool. So, what is going on? This might need to be louder. A lot louder. There's still no... The delay line itself is too long. Hey, there it is. Okay, so I just that delay line was short, but it wasn't short enough. Because this has to be, I think it's on the order of a cycle is the right length is my memory. So, and then we can tune it a little bit by changing the length of the delay line. So cool. Okay, so that wasn't too bad. A little bit of stupid code, but now we have karplus-strong. And this is nice. These sound little plucky sounds. I don't really know how to work with karplus-strong because I built it a couple of times. Never with this system before, but I haven't done much with it. So this is just going to be me playing. Okay. Possibly hear my cat, who maybe wants dinner. I think she's already been fed. Okay, so that's a real tappy rhythm there. Just a fast tempo. I want to make this do something interesting, so let's modulate the delay length. So we're going to do... So this is a sine wave that only produces values between 0 and 1. And we'll give it an LFO frequency. And actually want to rescale this. So now I'm going to make the actual KPS mod, which is a rescale node that maps a value between 0 and 1 to some other range. And the range I want is what we're working with for the delay line lengths. So I don't know how short is too short, something like that. I don't know how long is too long, something like that. But we will find out. Okay, so now I've got a rescale that will, at the rate of 1 hertz, wobble between 0.03 and 0.09. And then we're going to use that as the delay line length multiplier parameter. And that should sound different. And indeed it does. Okay, let's just go back to not quite as frantic. I was a little bit worried there was going to be weird artifacts. from running the modulation on the length. But it seems to work. And by doing it faster, I can make it loop a little bit. If I make it like audio rate. Huh. Sounds percussive. Yeah, but I think this is sort of the sound I'm going for, so we're going to do that. So let's experiment with this range a little bit. Like, what if I make these quite a bit longer? Lower sounds, cool. And then shorter makes it more sharp and plucky. Okay. Cool, so now it's basically playing random notes. I mean, they're, it's a sine wave modulation, but it's not really selected. I could sample and hold to get it to not do that weird, like, portamento stuff, but, like, you can't really hear that. It's like there's a little bit of, like, whoop, which I think is the delay line changing size on those longer notes. But I kind of like it, so let's do that. One interesting thing about this is you can hear the click. I don't know if you can ever get rid of that. It's going to be really loud. Actually, not too bad. It'd be nice to be able to control that click some. For this, just use it as a percussive sound. That's fine. Really know what the impact of this parameter is. Like, this stuff should decay faster. But 7, that was my things fall apart number. Yeah. We'll just keep it at 6. I'm not actually certain why 6 is the magic number here. I mean, it has to do with like, I would expect anything other than a 1 to be fine. So 0.6 is kind of surprising to me, but I'm sure it makes sense. So I play this filter a little bit. What if I get a little bit sharper? And basically just quiet. I can beef this up. It's still just pretty quiet. So I kind of like the 400. That doesn't seem to be about right. And that's kind of nice on the longer ones. The longer delay line. It has like a deeper boom, boom, boom. What? Because this is always fun. If I make this filter a little bit resonant, what happens? Gets pretty close to blowing up. You can hear the resonance. It's interesting. I don't like that. Okay, cool. So now I have a real basic karplus-strong, and that's pretty spiffy. But one of the things I wanted to do here is make something sort of complicated and sparkly, and ideally might even try and get rid of the tempo. Could be a little hard to do. Just get rid of the clock entirely and rely totally on cross modulation. Yeah, that might be too much to ask for. Okay, so I want to make this break up and do some sort of noisy stuff, because that is a sound that I like and have trouble actually getting. So what can I do? So I have this bridge that's giving me, basically this is the output of my string sound. So what if, for instance, instead of actual noise, what this is going to be, who knows? Nothing. I'm curious to see if we can make this work. So if oops. I don't really even know what I'm expecting this to do. Shouldn't be different in terms of modulation. Wait. Just make it too. Maybe it's because it's. I'm expecting to hear something that's not just it fading to silence. Could be because it's actually inside the noise envelope. So that's, I don't know, maybe it's just not the right thing to do. Okay. So what else? What else can I do? If I... So I have the... noise envelope is coming from tempo. What if it talks to itself as a trigger? Come on. Okay. Too loud. Grinding and aliasing. Could be. Just it's not that it's aliasing, it's just this re-triggering really fast. In which case I could try just doing a really aggressive low pass on this to get it calm down a little bit. So give it like 10 hertz or something. Of course, now you can't really tell it's there at all. So there, now you can hear it. You can hear it re-triggering. Not just on the tempo. That's interesting. Now I wonder if I could get it to actually self-oscillate. In which case, this, instead of a sine wave, I would have the tempo be... I don't have a constant value thing, so it's going to be value 1, which would give me one trigger right at the beginning. That does nothing. Yeah, so there you can hear when the engine starts, you get that one trigger, but it's not actually enough to kick things off. getting me noisy stuff before, but interesting. I feel like there's some way I should be able to get this to actually self-oscillate. I'm not entirely sure why it's not. Why wouldn't it be? KPS. Could it be this is just too quiet? Oh! No, it's because... Let's see, this doesn't work how I think it works. Because the, that add value is always 1, which means the trigger basically just latches on. And I need it to turn off. How do I do that? This is dumb. I'm trying to fake a thing because I don't already have a node written that does this, but turns out I have the code. So what I'm going to do is so I have code that just in the constant value, like the most boring node. But what if I do constant on load? So this is going to send whatever value generics are too hard to think about. It's going to send, call it load. And it's just going to be a bool. And don't care about the generic anymore. Takes no input. Its output is a control voltage type F32. And so what it does is it goes, if it has previously triggered, this would be false. When we started on default, it would be false. So if type 0, whether or not I've triggered, then my output is just a 0. Nothing. Otherwise, I record that I've triggered and send pulse, which is going to be a 1. Okay, so this will, every time this node gets loaded, it will send a pulse once. And I can't resend the pulse by like writing the node files because I don't reload nodes unless they're type changes, so I'll have to restart the engine, but that's fine. I can deal with that. Okay, so now I need to make another one of these guys. This is going to be pulse on load. It has the default. Thing I'm going to be using all the time, so I don't really care if it's verbose to type. Okay, so now that should build. Go back to this. In which case, tempo becomes pulse load. I get 1 pulse. No. I've got a typo, which is did send my polls. That's good. Still not retriggering. That's interesting. So let's just verify that this is doing what I think it does. So I have a cheapo logging thing, which just outputs a stream of zeros. Okay, so that is what we expect to see there. But the fact that we hear a sound at all implies that it did trigger once, so that's working. But it's still not retriggering, so why is that? It seemed like he was on the edge of... But no, still not that. Why? Why is that? There, it looked like it re-triggered for a little hard to see because it just flashes past the screen, and probably in the recording won't be able to see it at all. There's a couple there where it does seem like it re-triggers, so this may just not be loud enough. Got two things. I think this is just going to go straight to noise. No? Now there was something. It kept going for a little while. Hey. Cool. What is it doing? This is something I don't understand here. AD. I mean, just keep turning this up forever. That's not really the problem. Sounds like it triggers twice. Sometimes. Boom. Is it just that as things are dying down? There, it clearly triggered a bunch of times. Okay, that's why you get that growling. Okay, I don't know. This is getting long, so I think I'm going to stop and come back to this later. Because that's a lot of fiddling and not really going. Okay, so last time I was trying to... I got this karplus-strong voice working, and I was trying to get it to self-oscillate in some interesting way, and spent quite a long time trying to figure that out, and not much came of it. So I think I'm going to set that aside and think about some other ways of doing this. One thing, as I was sleeping on it, I did realize that I'm not doing that I probably should, is interpolate the samples inside the delay. So I'm actually going to do that real quick while I'm thinking about this stuff. So this is the modelable delay that I wrote yesterday, and and it calculates an index based on the current delay length. So that's this stuff. Delay scale. I don't know what the right term is. Scale, I guess. And this is the thing I need to interpolate on. The problem with interpolation here is I don't really know how to interpolate in these wide blocks. So I'm just going to give up on that, and instead I'm just going to store floats. So I'm no longer 8 wide in my delay line. So this makes the delay line a little more expensive, but I really don't think that matters. But I have to do a number of things differently as part of that. And those things are, this stuff needs to get wrapped in. Well, I'm just going to fix this. I didn't like that I unpacked that initially. It was the wrong thing to do. So just while I'm thinking, make this easier to look at. Still need this. Okay. But that means what I need to do is I need to actually build a response value, which conventionally I call R, because I still want to send my responses back in blocks. So that is, I'm going to keep doing that. And then this is the part where I'm not really benefiting from all my explicit SIMD stuff, because I'm just going to go so I've got a loop, and I'm going to walk through every lane in my SIMD value and do stuff with it. And then I change this up in the middle a little bit, but when I'm done, what I'm going to actually send back is this result that I've constructed. So now I just need to figure out how to construct the result. Okay, so now every tick through the lane is a sample, and my indexes are per sample rather than per 8 sample block. So this stuff actually doesn't need to change. What does need to change is I'm no longer putting the whole block into the delay line. So I need to actually unpack that value. So I'm gonna shadow it here because I think that makes it easier to work with. So I pull this lane out of that value. And so now that's a single float instead of an 8 float block. Okay. And this is no longer the right thing. So what I need to do is I'm going to have to interpolate between this, which is my line end, and a fractional part, t, because that's, I don't know, I think about interpolation in terms of time. Because this is right now, it's a fractional or a floating point index that will have fractional values. So I get the beginning, which is, I don't think this changes anything, but just for clarity, show that that's the floor. And then these are the two values on either side of my actual index. And then I'm going to calculate a final value by interpolating those. So that gives me A times 1 minus t plus b times t. Yep, okay. And then I stuff that into my result. And and every single time I do this, I forget that that's not actually in place. Okay. So now everything in terms of the API is the same, but internally I'm interpolating those values, and so it should sound a little bit less crunchy. Okay, so let's just go back to using sine wave to set this off. Who knows what that was? Well, that was working anyway, so we're just going to ignore it. And I think that's everything. So now should be able to build this, and it should sound basically the same as it did before I started trying to work on the self-oscillation stuff. It did not. Right. Okay. Because this value might actually overshoot the end of the array, so I need to mod it again. I could probably do that somewhere else and avoid that calculation, but that's fine. Okay. Boop, 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 boop. Okay, cool. Now, we may or may not be able to hear the results of that interpolation, but it is certainly more correct than what I was doing before. Cool. I like karplus-strong. It's such a nice, like, bloopy pluck sound. That's cool. Okay. So the thing I decided I'm going to do, instead of trying to do the self-oscillation, and maybe I'll come back to that, is just build some other voices. And I'm going to try and do them by bandpass filtering noise. So I have a noise source already up here. So I'm just going to reuse that. And I'm going to go... just not really an oscillator, but called an oscillator. So this is an SVF bandpass filter, and we're going to give it a frequency of my favorite frequency, 220, and start with no resonance or drive initially, and then we're going to feed it the noise. And then I will... I think I'm going to set up a mixer, because that just is a nice thing to do. Again, I don't have a great way to do mixer, so I'm just sort of faking it with an addition node. Also, I don't have a good way to do this in stereo, so I'm doing 2 different nodes, one for each channel. Okay, so then instead of this going into the output, it's going to go into left and right. And right now there's no stereo space at all, but eventually I would want that. So just make sure it's possible, and then put this up actually near the instrument that it's representing, and then we're going to actually feed those channels into the real output. So having this mixer lets me do things like put a global filter or whatever if I want. Okay. So, and also makes it a little bit clearer to me, at least, when I add these extra voices in. So I have the karplus-strong voice. Now, what this should be is basically just a sine wave type oscillation. I might have to adjust the frequency a little bit. Yeah, not that. If I make this tighter, can I make it resonate? Not that. Sorry. I'm going to have to go in and edit those out because they are real unpleasant. Okay. I'm going to turn that one off for the time being and just have this I actually kind of like it as a like deep sea rumble. That's a sound I always like. But I was hoping I could give it more of a pitch using this band house. Maybe that just doesn't work. Like, it's clearly, you can hear it change the pitch. But it doesn't really cut out as much of the sound. If I stack them, I'm revealing that I don't really understand how filters work. But maybe this will work. Okay. So that actually did sort of do what I want. I probably want the resonance on this one, not on the other one. That didn't change anything. That's interesting. I don't know why that would be. Those sound exactly the same. Okay, whatever. That's still, I really like this sort of wobbly sound. But I would like to reduce the noise further. So let's just see if stacking it again helps. Okay. That's actually pretty nice, but I don't know. I don't know what I was expecting, but since I don't have great constants yet, I actually had that in an earlier version of this, and then I took it out and never put it back. So that's my version of the constant. It'd be interesting to put this through an oscilloscope and see how close to in tune it is. That is what I want. So there. Yeah, that's more of a wind sound. More of a sea sound. Okay. What if I... You can hear it. It gets real loud when I guess the noise actually hits that pitch somehow, which is why you would get those clipping the way it did, I think. I'm also pushing that pretty hard. Okay. And it's just real loud, I guess. Okay. Interesting. What happens is this play notes. Let's just give it a sequence real quick. 20. Try that with tempo. So this is a really, really basic sequencer. And that's our pitch. You can hear it change. Not a real recognizable note. Kind of like that though. I did when I started. I explicitly said I wasn't going to use a sequencer, so I guess I have to follow my rule. So how would I get a similar effect without a sequencer? And I also want it related to the karplus-strong pluck. Although I guess since they're both tied to the tempo, they're pretty in sync. I kind of like it. That's cool. Okay. But still, I don't want to have a sequence. So the karplus-strong has its modulation. I could use the same modulation, maybe. Or... Okay. Yeah, so nothing in the karplus-strong modulation, like I'm looking at this stuff, is, there's some relationship between delay line length and pitch. I don't really know what it is. But it's there. And I'm sure there's some math you can do to calculate it. But what if I did make this a multiplication instead, and so I'm going to say there's a relationship between the karplus-strong modulation and the pitch of my drone sound also. What I want to multiply this by to make it similar to what the karplus-strong does, but something. Okay, clearly that's too low. I can hear it rumbling, but... Interesting. That did not do what I was expecting. And I guess it's because that modulation is actually a sine wave. And I'm not hearing this sine wave effect as much because the karplus-strong has this weird pluck thing. Okay. So then I need to do something to make a note on the drone. And the simplest thing is to go this. This is a sample and hold node. So the thing I'm going to sample is the drone pitch. And the trigger I'm going to use to cause it to sample is tempo. Maybe I have that backwards. Yeah, there we go. Cool. I actually kind of like that. There's some clicking in there maybe, but that might actually be the driver for the karplus-strong that I'm hearing. But I think there's some other artifacts too, which is probably the drone suddenly changing its pitch because of the sample and hold. So I actually have a way to fix that too. If I do sample and hold, but I need a better way to pipeline this kind of stuff rather than going raw 2, raw 3. That's ugly. So I can make this slide between notes, which I think will get rid of those artifacts. I can make the slide really extreme. Not that extreme. Yeah, so I could hear it. This number is pretty arbitrary right now. It's a multiplication on the sample rate to make the time. It is because I was lazy when I wrote this. But it's you can just twiddle with it until it sounds right. Okay, yeah, so that did get rid of some of those artifacts, and now so you can hear it sliding, which is kind of cool. It does occasionally clip, but I think I could fix that just by whatever. I'm not going to try because it's not happening that much. Okay, cool. So I kind of like that. One thing that I don't like is how regular the tempo is, because I wanted there to be some sort of rhythmic component to this. So, I mean, one thing I can do is I can modulate the tempo, but let's try this. So if I make a second tempo, or being more organized about this, I might think about this in terms of like eighth notes and quarter notes or something. I'll just make it twice as fast. And when I drive this, I guess. Yeah, it's coming off that same modulation source. Yeah, whatever. Okay. When I drive this, is it the only place I'm actually referencing tempo? Oh, no, there it is. Okay. Yeah. So when I do this, I'm going to say it is tempo plus tempo 2 times a thing that doesn't exist yet. And this is going to be my KPS comparator. I actually don't know if I remember how to spell that. Okay, KPS comparator is a comparator. I'm pretty sure that's what I call the node. Between I gotta look up the node. I don't remember how it works. Or how it's spelled. Cool. So it takes two values, I look at them, and if the first one is bigger, I return a 1. Okay. Okay, so it's going to be, my first value is actually going to be the filtered KPS. This is my sound. And we'll just try 0. So this is going to be 0 or 1. It's going to be 1 when that signal is above 0 and 0 when it's below 0. This is not as interesting as I think it is. Let's see what it does. Nothing. No definition for comparator, so I don't know how to spell. class and use an abbreviation. Still can't hear it. Yeah, so you can see it triggering. So every time actually in the recorded video you might not be able to see this, but every time the karplus-strong pulses, there's a little burst of zeros go past, and so that means that it's 1 most of the time, which means I'm mostly using the sum of the 2 tempos, which should be, since those are used as a trigger, should be basically but it's a sample and hold trigger. Yeah, okay. So that should be going basically twice as fast as the bass speed. And I think you can actually hear that it's a little more subtle than I would expect. It is subtle because the portamento. Let's just not have that for a second, so that we can actually hear what's going on. Maybe that's better. So, because now it does have a little bit of a rhythm to it. It should be mostly 2 pitches per. Yeah, it's too deep. Okay. It's a little bit irregular, which is what I was looking for. Like it's clearly related to the bass tempo, but it's a little bit stumbly, and I think that's cool. So can if I flip this? Okay. Just sitting there in a trance listening to this thing make its noises. Cool. Okay, so I'm actually pretty happy with that. I want to speed this up a little bit. Yeah, that's a lot better. Okay, cool. I like that a lot. I think I want the plucks to be higher now, which I think means I need to make the delay length shorter. So this needs to be like that. affected both of them now, which may be undesirable. Cool. Okay. I like it. Yeah, too screechy. Okay, cool. Yeah, I like that a lot. But I want there more. I want there to be more. So another voice. So let's just start with a copy of that other voice, of that initial voice. This really shouldn't be interesting. Just louder. And probably just need to turn this down in general. It's not going to get quieter. Okay, so now if I offset this and I could try and do like a proper musical interval, but I would have to look up what those numbers are. So let's just do down an octave, because that is the classic thing. Although I think that's going to make it too bassy. Yeah, I can barely hear that. I mean, if I had a wall of speakers, it might be cool, but... it didn't change it the way I was expecting it to. Oh! Because I'm not doing what I think I do. There we go. Okay. I need this sound to be somehow different, because right now they're too fused to really even tell them apart. So I'm going to try and wobble it, give it some vibrato, and just see if that helps. I don't think this is going to be... This is not really the solution, but... Okay, type. And now it's, since I'm modulating the frequency, so I get a little bit of FM here. It's I guess I said vibrato earlier. That's really not what I'm doing. This is FM. And that's... I was not expecting to like that, but I actually do. That's too loud. I might want to slap a filter on it too. Yeah, I think I want a low pass filter. That's too buzzy. Okay. I like it. Okay. I like that. I want more long-term variation, because this is giving me that sort of rise and fall on the order of 10 seconds. And where else can I slap that? Yeah, I guess these two are tied to each other. But I can do this. I want these. God damn it. There it is. I was expecting that to... this just isn't where I want that. I want something that's out of phase with the other one, 180 degrees out of phase. But that doesn't seem to be the right place to stick it, so... Let's do that. So if let's do between 300 and 1,000. Let's see what that does. And it's going to take flipped LFO2. That should make a change in the sound of the karplus-strong. It's a little tricky because I've done the thing I intended to do, which is tie these guys together through cross modulation, but now I can't get them to operate independently. Which is, well, I guess the thing that ties them is this, so I can actually manipulate this maybe. That sort of changes the rhythm of the droney voices. Okay. So I'm actually pretty happy with this. This is mostly what I set out to do. I mean, he's in the class of things I set out to do, since I didn't really have a direct goal. Okay, yeah, I like this. I might actually come back to this and try and make a song out of it, like something with a little more structure, because that seems like a neat project. But for now, I think I can just be done. Cool.